Good afternoon, everyone, and appreciate you joining us for the next in our continued series of webinars. Today, it's a pretty specific webinar on coated board machines and the improvements that precision calendar rolls can bring those operations through yield and other quality parameters. Again, we thank you for your time this afternoon. We hope that you're all staying safe and secure as we continue to work through all the COVID issues. Just a few housekeeping items. Throughout the webinar, folks are muted just so that we prevent background noise from coming in and distracting the webinar. However, there is a chat function in your webinar. Feel free to ask questions through that chat function, and we'll also unmute everybody or give you the opportunity to unmute at the end of the webinar and ask questions as well. So with that, we'll go ahead and get started. And again, if you have questions after the fact, within a few days, this webinar, along with some other information, is put on our website. Please reach out to your local account manager, call one of our shops directly with any questions you may have. We're obviously happy to follow up with you. So calendar roll performance and coated board, what are the key drivers? And this is not inclusive. Each mill, each machine has its own specific drivers. But as a whole, the industry is really, these products are consumer products. They go on the shelves of the stores that we all frequent. So what are those key drivers? Sheet smoothness. Obviously, world-class sheet smoothness is critical. It's a competitive market. Customer print demands will continue to increase. Multiple colors, the register, the distinct lines, the depth of print, all those things will continue to increase as your customers in the paper mill improve their marketing and their presence on the shelf. Caliper control, obviously, lowest possible caliper variation is critical. Not only for your customers' converting operations, but for your paper machine's runnability as well. Reducing variability anywhere on a paper machine is obviously healthy in coated board grades, particularly with caliper. And as a combination of those two, yield is really a big financial driver that we found with our partners in the coated board industry. Being able to provide world-class smoothness and the best possible caliper control may allow you the ability to move the levers on your paper machine and reduce fiber. And fiber is a huge driver of late. There are pressures in the pulp markets that we haven't seen in a while. So it's also, even without those pressures, it's probably the biggest cost in your operation. So we're going to center the conversations today around those drivers. This is intended to be more of a technical presentation, things that we would ask you to consider keeping in mind when working with your roll service providers. If that happens to be us, it keeps us honest because we're committed to driving value into your operation and validating that value statistically and showing you the numbers, specifically in the form of dollar signs. But we'd also encourage you to keep that in mind when you're dealing with any roll service provider, because I hope you'll see by the end of this webinar how critical it is to have really well-performing calendar rolls. Okay. So calendar roll performance with respect to smoothness. There are reasons that the original equipment manufacturer specified roundness of chilled iron calendar rolls at 2/10,000ths of an inch. This becomes particularly critical with coated board because of your surface finish characteristic properties, the demands on those properties, the demands on maintaining caliper, all those things. So calendar roll performance equals consistent world-class smoothness. The picture on the right-hand side I find particularly helpful. It's a series of nip impression paper that was actually put through a calendar stack in the machine direction, or in the direction obviously that the web runs, and you can see what we call barring, but you can see that machine direction variation in those roles. Those are roles, calendar roles, that are exhibiting out of roundness. That can't help but show up in the sheet of paper that you're producing. The picture on the left shows why the lack of deformation is so important, not only for what it imparts on the sheet itself, but just for the length of time that you should be able to run calendar rolls without having to change them, because you're seeing what's on that bottom right hand side. This graphic shows a calendar roll that starts at the OEM specification of 2/10,000ths, and that OEM specification is on diameter, not on radius. So one of the things we encourage you to be aware of when you're reading the reports from your roll service provider is whether or not they're measuring roundness and total indicated run out on diameter or radius, or roundness on diameter versus radius. So that's 2/10,000ths on diameter, so that's 1/10,000th per side, if you will, versus another roll that started at 8/10,000ths. And I must admit, I spent the first half of my career in paper mills, most of those being linerboard mills, and 8/10,000ths seemed like it was plenty good. But I didn't know this graph. At 8/10,000ths, and this is a real life case, in 6 months, you're reaching a point. It was the case for this mill, maybe a different number for your mill, but the relationship stays the same. Reaching a point where you're either seeing what's shown there on the bottom right hand side, or some other indication on your paper machine that, boy, we got to regrind these calendar rolls. If you start at 2/10,000ths, the wear of that roll is a function of its deformation. So starting that much closer to perfectly round makes a big difference, and it's not a linear relationship. It's actually, it grows exponentially towards the end, as you can see. So it took a year's time to get to the deformation that this mill in particular had started with new grinds from the previous roll grinding provider. So just asking you to keep those things in mind because of the impact it has on your sheet properties, particularly smoothness. So what does that look like? Again, OEM specification on calendar rolls, barring must be removed entirely. In just about every case, when rolls come back from a roll service provider having been ground, you cannot visibly see barring in them. However, sometimes it shows up very quickly, sometimes it doesn't show up as quickly, sometimes it takes a while to show up. There's reason for that. That barring has to be removed. And these are two examples. The one on the left happened to be a roll that was ground in bearings. You cannot properly remove what you need to remove when it's ground in bearings. A precision ground roll should be ground onto journals, so that not only the barring can be removed and the roundness at OEM specification be achieved, but the concentricity from the center line of the journal to the face of the roll as well. There are a myriad of reasons why the geometry only works if it's ground from that journal, and that journal is known to be proper, so that you can get that concentricity and you can get the roundness. If not, you're virtually putting a cam back into your calendar stack. It could be very, very slight, but that slight cam action over time builds the wear into the rolls, which ends up showing up in your sheet properties. So again, be looking at these. We would encourage you to really look at the scale on roll reports that you get as well, because as we all know, as engineers, you can make a graph look fantastic or you can make it look awful depending on the scale that you use. So not accusing anybody of anything, because depending on the rolls we're working on, the scale might be different too, but make sure that you're just comparing apples to apples when it comes to the scales that you're looking at on your roll reports. Caliper control. Again, we start with the graphic that you saw with the nip impression paper run through a calendar stack in a machine direction, and the subsequent reel that it may build. And I saw many of these running linerboard for a lot of my career. That's an indication that something in your calendar stack isn't right. There's an old adage that you can do, a whole lot of good all the way down to paper machine and mess it up at the calendar stack. There's a lot of truth to that. So again, it's a critical unit operation on your paper machine, particularly with coated board. With coated board, it's multiple unit operations on your machine. The big thing that I don't think is real prevalent or real well known in the paper industry is the impact on strength that caliper variation can have, particularly in the machine direction. FP Innovations has done a lot of work around this. It's an independent group that has shown that caliper variation as low as something in that 2 to 4/10 thousandths range can lead to strength variation of up to 20%. And strength is key on any grade, particularly when you're trying to maximize yield and perhaps limit the fiber needed to get the gauge and to get the smoothness you need on a sheet of coated board, right? So you don't have as many bonding sites. You still need the strength, and you don't need the calendar stack on the other end of the paper machine, uh, inducing that machine direction variation and very potentially affecting strength. Again, not only is it a machine runnability issue for you perhaps, but just convert it, winder runnability, downstream converting, downstream printing on these grades that are really, really critical. So again, all the around the proper roundness, the proper geometry, the proper concentricity of your rolls, we encourage you to really look through that with your roll service providers, because millions of dollars can come down to tens of thousands of an inch. It truly can, particularly in coated board operations. So I know this is pretty elementary, and I apologize for those of you that have deal with this on a daily basis, but we did want to illustrate it because we've been able to partner with folks to really impact yield. And just a rule of thumb that we use, every 1% yield improvement or 1% less fiber you have to put in coated board is somewhere around $1 million a year of return on that investment to your paper machine and to your mill. So with inconsistent smoothness and caliper, generally what happens is you end up loading the calendar stacks, right? The calendar stacks will correct that. Sometimes it can correct all of it, sometimes it can correct most of it. But a standard calendar roll grind is inducing the kind of variability you see in the upper left-hand corner there in your board. So you load up the calendar stacks, it provides the smoothness that you're looking for, but you have to maintain a certain caliper, a certain gauge. So there's only one way to do that, and that's to put more into to the sheet, whether it be fiber or filler, and that costs money. So if you can start with world-class smoothness and caliper and reduce the load on the calendar stack to maintain the caliper gauge that you need, pull fiber out of the process, it's huge incremental savings that really go to the bottom line, because you're already covering your fixed cost doing what you do, and fiber probably again is the largest variable cost for your operation, if not the largest, one of the top three for sure. And recently even more pressure on fiber cost. So precision calendar roll grinds really ought to be looked at not as a necessary maintenance cost, but we would encourage you to look at it as an investment. On many calendar stacks and coated board mills, the money you spend for servicing a stack of calendar rolls is equivalent to what you would generally have to write a capital request to do. So again, we would encourage you really look at it that way. Push your roll service provider to provide a return on that investment, because you're spending tens of thousands of dollars to get roll grinding done and roll servicing done. So it needs to return that investment back to you, in good order and with good ROI. So I would talk a little bit about a world class, or a real world, I should say, world class too, but real world case study. Mill was experiencing this barring that we've represented in earlier slides. Um, Worked with us to get to those OEM specifications or better on calendar rolls. It eliminated the sheet barring. MD caliper variation improved significantly. Sheet smoothness improved significantly because of that. And they were able to do what was represented on the earlier slide. They were able to reduce the calendar loading while maintaining those world-class quality parameters around sheet finish, smoothness, caliper, low variation. It improved the yield in this case by 1.75%. So almost a $2 million a year savings. And we'd ask you to look at it this way. Assume that, some other roll grinding cost is free. If you get precision roll grinding, the kind of roll grinding the OEM specified for a reason, the kind of that was expected, the ROI is less than a month, even if you assume that somebody else could do it for free, or you have in-house facilities. Again, proper precision counterstack grinding and maintenance should be treated as an investment, not just a necessary cost. So the drivers in coated board mills, whether they be solid bleached, recycled, recycled's a little different story on yield, but again, smoothness, print quality, caliper variation, all the things, these products are being converted into consumer products. So the makeup that our significant others buy, or that the beer we carry home on Friday night, those kind of things, they are consumer products. So you know better than I, the quality parameters and the quality demands that continue to get tighter and tighter. So again, work with your roll service provider to look at this as an investment, and how best to do that. And we'll talk about that in another slide or two. There's some other ancillary things that this can really help. Less scrap. Right at turn up, if there's spool losses because the sheet's wanting to wander, sometimes that can be directly correlated to calendar stack performance. Being able to reduce the amount you run back into the dry end pulper is a big cost for mills. It can also translate downstream to winder runnability. And this is just another real world case study. 250 pounds per reel. All right, that's 1,000 tons per year in the case of this mill, right? But it doesn't take much on every reel. It doesn't take much to get to 250 pounds, matter of seconds. So these matter of seconds over time really add up. Again, this is just taking the view of your roll servicing and particularly roll grinding as an investment, not as a necessary cost. We talked about roll life and extending the roll life in your facility. This is real. This comes down to geometry and the fact that the wear on a rotational piece of equipment is a function of its deformation. It's just like the washboarding effect on an old country road. Once it starts, it doesn't fix itself, and it gets progressively worse faster as you go. Your rolls, and particularly your calendar rolls, are doing the same thing. Just talk a little bit about the other pieces around it. Particularly with calendar rolls, you have controlled crown rolls in various shapes, forms, and sizes. Be comfortable that your roll service provider is really capable of doing those things. In many cases, people are only comfortable sending that work to an OEM. You might want to consider sending it to a roll specialist. as opposed to just a machinery OEM. So again, roll life and startup, it also comes down to mechanical excellence. And let's talk a little bit about how do you figure out whether or not you're getting a return on investment? Well, providing value in a virtual world, which we all are in right now, your role service provider should be partnering with you to improve your process and reduce variation. They should be asking you for data. They ought to be providing a service that takes that data and takes a look at it over time and compares it before and after roll service, and particularly roll grinding, to ensure that the parameters that are the key drivers that we started the webinar with are being improved. Really take a Six Sigma type approach, put that kind of Six Sigma rigor to it, where you're designing an experiment, you're coming up with how to measure it, you're analyzing that data, you're improving, and then you're controlling. The whole DMAIC set of steps that Six Sigma represents. That's something that Precision Roll Grinders commits to doing. We have an application engineering group that'll come in and work with you to do that. And unfortunately, having grown up in the paper industry, the technical teams, the technical groups, departments that I entered 30 years ago as a process engineer are really not there anymore. So lean on your role service provider to provide some of those services. They ought to be. And it really ought to look like a Six Sigma project. Doesn't necessarily have to have all that data, but it can. So how do you design an experiment that makes sense for your paper machine and for your mill? How do you analyze the data? How do you implement a plan to improve the variation and then keep it there? And then eventually, how can you build a predictive equation where you can expect a certain level of performance in calendar roll grinds or other roll grinds over time? That's really the rigor that ought to be driven through your calendar roll or other roll service provider and grinding provider. And at the end of the day, it's got to drive dollar signs for you. So with that, we'd like to keep these to about 20 minutes. I ran over 2 minutes because this one is I'm particularly passionate about this one because I've seen the improvements firsthand, and having been a paper maker for most of my career, I understand the struggles, the Pareto charts you're all working on in your mills to try to improve. And a lot of it really comes down to just reducing variability in your process, and particularly paying attention to the calendar stacks that we feel anyway don't get the attention perhaps that they deserve with respect to how it affects your process. So with that, let me unmute everybody. If you do have any questions, you should have control and unmute. We'd welcome any questions, and then we'll also answer any that have come in through chat. Here's one that's come in through chat. How long do these studies take? Quite honestly, they don't take as long as you might think. Generally, variability in caliper, smoothness, any other quality parameters or machine parameters, mills are pretty well set up with scanners along the machine, with distributed control systems, and with plant information systems where data can easily be accessed. Again, I don't know what our competitors do, but Precision Roll Grinders has application engineers and account managers that will work with each mill to just get that data, analyze it, show like we showed back here. Let me back up if I can one. We ought to be seeing a distribution like that before and then a distribution like that after, reducing variation and allowing you to shift the lever on the machine that is most economical. So sometimes it only takes a month worth of data before and after a roll change. We've also had studies go 6 months. We've had rolls that were running 6 months that now run 18 months to 2 years. and customers wanted to study that whole time. So it's dependent, but it doesn't have to take as long as you might think. Okay, there's a question. I need to go to the questions pane. Supply an email address to speak. Yes. I think the person that asked that question did provide an email address, so I will send you email address and contact information directly to your email on speaking with somebody. So I'll answer it here. Okay. Any other questions at this time? Let me look through the chat list. There's another one that came through. Do you have experience in different types of coated board? Yeah. Yeah, we do business in recycled coated board mills. We do business in solid bleached or bleach coated board mills. One of the things that I found interesting about precision roll grinders, or continue to find interesting about precision roll grinders, having grown up in the paper industry and been a customer of PRGs, is we didn't talk about it in this webinar, but the wide variety of work that precision roll grinders does. We do coating application work on many machines that aren't paper machines that allows us the opportunity to really study what tolerances do in that industry. We do business in metals, chocolate refining, plastic film, battery manufacture. There are a lot of different industries. Many of those industries have tolerances that are in the 80 millionths of an inch range on large rolls as well. So it allows us to better understand how tight tolerances might affect our primary industry, which is still the paper industry. So having that ability and not just being a paper mill service provider, I think provides a better knowledge base to work with you on. But we do have experience in really every type of paper manufacturer, even tissue. Okay. Are there any other questions at this time? Well, listen, I'm not afraid. I'll give out my email address right now too, but many of you probably know your local account manager as well. But you can email me anytime at doug.thompson, THOMPSON, at precisionrollgrindersaltogether.com. And we'll certainly get you in touch with the right people through the application engineering group. We have a really extensive experience in our account managers, not only in paper, but in just roll services in general. I've kind of blabbed about my background, and we've got other folks that understand other markets really well that can translate that knowledge into paper too. So I'll check one more time, see if there are any other questions. Okay. Well, again, we're right at about half an hour. Thank you so much for your time. This will be available on our website. We'd encourage you to get out there and take a look at it. We have other webinars there too, specific to the paper industry, specific to other industries that might be of interest to you. So again, thank you for your time, and we hope to talk to you soon. Goodbye.